Welcome back to my next video lecture. In the previous video, I was discussing about the design of a battery system for UPS system. Okay, design of battery system for UPS application. And whenever I was talking about the design of battery system for the UPS system, basically we are calculating the size required for size of the battery required for the UPS system for a particular application. Okay, and we have solved even one numerical. We have seen the different relations. If you are new to this video, please go through my previous video lecture. Okay, so let me continue. I have told in the previous lecture video that I'm going to solve two more examples of different types. Okay, in the last video we have solved one numerical wherein we were estimating the size of the battery. In turn, size of each cell, voltage rating as well as power rating, how many jars are required in a battery system. All these things we have discussed in my previous class. Okay, so now today I'll take a different numerical, slightly different. Let us see how this can be solved. Okay, so we have a numerical wherein we have a UPS system. Go through the problem statement. A UPS system is driving 600 watts load. So load on the UPS system, let me just list out the given quantities. What are the quantities that are given? Okay, so load on UPS is 600 watts. This is mentioned, and it has a lagging power factor of 0.8. So power factor is also mentioned, which is nothing but cos phi, and it is given that it is 0.8 lagging in nature. Okay, and battery yeah, and battery voltage is 24 volts. Battery voltage is 24 volts. Battery voltage is 24 volts. Efficiency of the inverter. Okay, this is a slight mistake here. You can just correct it. It is not a battery. Efficiency, I think even that is missing over there. It is not getting displayed correctly. Efficiency of the inverter is 80%. That is what is mentioned. So percentage efficiency of the inverter is 80%. Okay, and battery voltage 24 volts I have written already. Assume that there is a separate charger for the battery. So this is a different type of problem. So here we are not really taking the previous two configurations. In the previous two configurations, charger used to be a rectifier which is taking the power from the supply itself and it was charging the battery. Now here they are asking us to ignore the battery charging process because we have a separate or external charging for the battery. So when we have a separate battery charger, right, he is asking us to determine the following. What we are supposed to determine? KVA rating of the inverter. So first thing that what I am supposed to find is the KVA rating of inverter. KVA rating of inverter, how much? Next, wattage of the rectifier. So here rectifier is only converting AC to DC and it is supplying inverter, in turn it is supplying the load. Remember, now the rectifier is not acting as a charger to charge the battery because the assumption is given in this particular problem that battery is charged externally by external or separate charger. So rectifier function is now not to charge the battery, rather only to convert AC to DC load power, and DC to AC will be converted by the inverter. Okay, so wattage of rectifier we have to find in such a way that it is feeding only the load and inverter losses, and not feeding the battery. This is what we are supposed to be very clear about it. And finally, AmpereHour rating of the battery for a backup time of 30 minutes. So here this backup time is also mentioned. So backup time of battery is 30 minutes. And now if I convert this into hour, it is 1/2 hours or 0.5 hours. So AmpereHour rating of battery we are supposed to find. So these are the things that what we need to calculate. So let us calculate these things one by one. Okay. So here we are asked to calculate KVA rating of the inverter. Please remember what would be the configuration of this type of inverter is. Here you are having a rectifier which is converting the given AC into DC. So here you have the AC input. It is converting that AC into DC, and that DC is given to a inverter block which is converting that DC back to AC, and it is feeding the load, critical load. Okay, so here intentionally I am not writing the positions of switches just to simplify the diagram. Now here we have the battery backup as well. So you have battery backup as well, and this battery is feeding the inverter only when AC fails. Okay, and charging of the battery is done by a separate AC source through the separate charger. Okay, so for this again AC is given. So according to this problem statement, configuration looks something like this. AC is getting converted into DC by this rectifier, and this will be further converted to AC by this inverter. Whenever AC supply is available, it is feeding the load directly, and whenever it is grid fails, that time battery supply comes into the picture through the inverter, it is feeding the load, but only thing is battery is charged separately. So in that case, what should be the sizing of the rectifier? What should be the sizing of the inverter? These are the questions that are asked to us. I hope the problem statement is very clear. Okay, now after understanding this, let us determine the parameters asked one by one. First one is KVA rating of the inverter is asked. Okay, but here remember the load power is given to us. See, inverter is feeding the load itself. So output of the inverter is known. Only thing is it is mentioned in terms of the active power, which is in terms of watts, and even the load power factor is also known. Okay, load power factor is also known. So output of the inverter itself is load power. So that at least that should be the size of the inverter. I hope you are understanding what I am talking about. Okay, now so inverter KVA rating. Okay, I will write inverter power, which will be in terms of VA. Okay, is equal to active load power divided by power factor of load. What is active load power? Active load power is 600 watts divided by what is the power factor of the load? It is 0.8. In that case, what will be the inverter output? 600 divided by 0.8. It will be around 750 VA, volt ampere, 750 volt ampere. And if I convert this into KVA, 750 divided by 1000, so this will be equal to 0.75 kVA. 0.75 KVA, 750 divided by 1000. Okay, so that will give us the inverter output in terms of KVA. So this is the sizing of the inverter. So first parameter we have calculated KVA rating of the inverter. KVA rating of the inverter is 0.75 KVA. Very simple it is. Okay. Now let us determine wattage of the rectifier. So how do you calculate wattage of the rectifier? How do you calculate wattage of the rectifier? So similar thing we have already calculated in the problem number 1. Okay, some clues are there that you can learn from the problem number 1. That clues you can take to solve this. Remember, your rectifier unit is behind the inverter. So rectifier has to supply the load power as well as it has to supply the losses in the inverter. Okay, very clearly. Okay, so because inverter efficiency is not 100%, inverter efficiency is not 100%, it is 80%. That means there are 20% losses that are taking place. That means if I give 1000 watts power to the inverter, output of the inverter is 800. Some 200 watts are getting lost in the inverter. So naturally, rectifier cannot supply only the 750 volt ampere of power to the inverter. If it does so, 20% of that is again lost. Power available to the load is lesser. Lesser by how much? 20% of what you are giving. So naturally, rectifier output should be greater than the inverter output. By how much? 20%. But remember, a rectifier output is DC. Rectifier output is DC. So you have to calculate the power of the rectifier in terms of watts. Okay, not in terms of VA, because it converts AC to DC. So rectifier output can be calculated as rectifier output, okay, which can be calculated as, right, it is inverter output or inverter power, which is nothing but apparent power. Okay, because I know that it is 750 volt ampere, it is the apparent power. So multiply it by power factor of the load. That gives me what? That gives me what? That gives me active power supplied by the load itself. That is nothing but 600 watts. Okay, to be very frank. Now divided by inverter efficiency. Inverter efficiency. So inverter power is how much? It is 750 volt ampere multiplied by 0.8 divided by inverter efficiency is 80%. That means if I convert it into a fraction, it will be 0.8. So now if you calculate what will be the kilowatt rating, 0.8 gets cancelled. So you will get 750 watts, or it will be equal to 0.75 kilowatt. I hope it is clear. Is it clear? Any doubt if you have, you can ask me the doubts by writing that doubt in the comment box, or I will try to answer to your queries in the comment box itself, or else you can I will clarify that doubt in the next video. Okay, so any doubt here you can always ask. I hope you understood how I have written this particular expression. If not, you can always write that query in the comment box. Okay, now I hope this is clear. How did I calculate the rectifier output? Okay, now the last one is to calculate the rating of the battery, ampere hour rating of the battery. Ampere hour rating of battery. See, a battery comes into picture only when grid fails. This comes into the picture if grid fails. Okay, and naturally it is supplying the same power which was earlier supplied by the grid in the presence of grid. Okay, so how much it was supplying is 600 watts that I know, or 750 volt ampere that I know already. Okay, but if I want to determine ampere hour rating, I should know the current, because battery power or capacity is expressed in terms of ampere hour. You know that current multiplied by time. Very simple it is. So how much current that battery is going to supply, if I can determine, I know the backup time, multiplied time, I can calculate the ampere hour rating or capacity of the battery. Very simple it is. So calculate what? First you have to calculate the current supplied by battery. Current supplied by battery when it was supplying the same load power. Okay, so how do you determine this? How do you determine this? How do you determine this? I know VA rating of voltage ampere rating, VA rating of load, isn't it? VA rating of load, which is nothing but VA rating of inverter itself, output of the inverter itself, divided by voltage, isn't it? Divided by voltage. Very simple it is. So I know what is VA rating of the inverter. What is the VA rating? It is 750 volt ampere, right? 750 divided by voltage of battery. Remember, what is the voltage of the battery? Voltage of the battery is 24 volts. So divided by 24. Yeah. Yeah. Now you calculate how much is the current that you will get. Please do this particular exercise. Please do this particular exercise. 750 divided by 24. What you will get? 750 divided by 24. Is it 31.25? Yeah. 31.25 amperes. This much of current. Check it out. Check it out. Yeah. So once you know this, now can you calculate ampere hour rating of battery? So ampere hour rating of battery is equal to current supplied by battery multiplied by discharge time or backup time, you can write. So that means it is 31.25 into, you have to multiply it by the backup time. Remember, it is given in minutes, convert it into hours. It will be 0.5 hours, isn't it? So multiply it by 0.5. See what you will get. See what you will get. 31.25 into 0.5. How much is that? 15.625. 15.62 ampere hours. 15.62 ampere hours. Approximately 16 ampere hours is the battery rating required. Okay, is that clear or any doubt here? Please let me know. Very simple it is. some common sense that what we are using here in calculating. Really it is not the stuff that is involved in this particular chapter. Look at the common sense. We are using the relations of apparent power, active power, etc. We are using the relations like ampere hour, current multiplied by time, to calculate so many parameters related to the battery. Okay. So I hope it is very clear. Okay. So with this, we shall go to, or I will give one more problem, right? And this problem I am giving as a homework to you. Okay. Please try this. It is a very simple problem based on the relations ampere hour efficiency and watt hour efficiency. Already I have discussed about this ampere hour efficiency and watt hour efficiency in my previous video. How to find out that. This is very simple. Okay. So directly the parameters are given, you can calculate. But I will read the problem once. Look at the problem statement. A 2-volt lead acid cell in a battery system. Okay. So you have a 2-volt cell, lead acid cell, and it is discharged at a uniform rate of 35 amperes. So it is the current that is taken from this cell is 35 amperes for 5 hours. For 5 hours. And EMF, right? And right, it is discharged for 5 hours, and EMF, average EMF is around 1.95 volts. Average EMF is around 1.95 volts. If it is charged again, if the cell is charged at a rate of 45 amperes for 4 hours, okay, if the cell is charged at a rate of 45 amperes for 4 hours, to restore the original voltage, determine ampere hour efficiency and watt hour efficiency. This is the problem that is asked. How to solve this? Once again, so let me write what are the parameters that are given. So what is given over there is, you have a 2-volt cell. So cell voltage is equal to 2 volts. And then see, look at the charging and discharging rate. That is very important as far as calculating this ampere hour efficiency and watt hour efficiency. Okay. So discharging rate, discharge current is around 35 amperes, and discharge hours, okay, discharge time is how much? It is 5 hours. Okay. Then you have charging data. See, if you have charging current, and how much is that charging current? 45 amperes. This is charging current. And charge duration is 4 hours. This is mentioned very clearly. Okay. Now let us calculate ampere hour efficiency. Okay. So first I am calculating is ampere hour efficiency. So how do I calculate ampere hour efficiency? Ampere hour during discharge divided by ampere hour during charge. Okay, so ampere hour during discharge is equal to current, discharge current, which is 35 amperes, multiplied by discharge time, which is 5, divided by charging current is 45 amperes, multiplied by charge duration is 4. How much that you will get? How much that you will get? And always this, this probably maybe 0.97, 972, isn't it? So now if I want to convert that into percentage, multiply it by 100, 97.2%. So this is the ampere hour efficiency of the cell. Okay. Now let us calculate watt hour efficiency of cell. Watt hour efficiency of cell. Okay. So what is the relationship that you have to calculate the watt hour efficiency is ampere hour efficiency multiplied by voltage, average voltage while discharging, average voltage while discharging. This I have already explained in my previous video. See, this is the relation that what I am using. Average cell voltage while discharging divided by average voltage of the cell while charging. Okay, now we have calculated ampere hour efficiency already. How much is that? It is 97.2%. 97.2% multiplied by average voltage while discharging. It is mentioned that I think I have not written that particular data. Yeah, just go through the problem statement. Average voltage while discharging, you can see when it is discharging, the voltage has come down to 1.95 volts. So 1.95 volts when it is discharging, and naturally you are charging with the rated voltage of the cell. What is the rated voltage of the cell? It is 2. It is 2. Okay. So now what you will get? What you will get if you simplify this? It is around 94.8%. Check it out. 94.8%. So this is how, look at this, ampere hour efficiency and watt hour efficiency values are different because you are not considering voltage when you are calculating the ampere hour efficiency. But to be very frank, voltage do change with your discharging current. If discharging is sudden, sharp, heavily, if you are drawing the current, naturally voltage of the cell will decrease, which will impact the life of the cell itself. Okay, hence discharging current has to be limited. Okay, to if you want to increase the lifetime of the cell. See, all these are engineering, basically tasks that are involved. So in this way, anyway, it's an introductory course, so we cannot go in detail about the lifetime of the battery, etc., etc. It's an introductory course. So some basics related to the UPS system, how to design the UPS system, how to select the rating of the charger, how to select the rating of the inverter, how to select the battery system. In that battery system, how to select the size of the cell, voltage rating, power rating, X, and how many jars are to be there. That means how many cells are to be connected in series, how many are to be connected in parallel. Everything we discussed through these 3 illustrative examples. Okay, with this we have come to the end of this UPS system configurations and design part 3. Thank you.